All right, next we're going to talk about the surface area of a revolution. So if the graph of a rectifiable curve is revolved about a line, the resulting surface is a surface of revolution. So basically, if we take this curve, which is y as a function of x, and we rotate it or revolve it around an axis, we're going to get this surface right here. And so you can kind of see if we revolve that around, what we're going to try to get is just a surface area of a revolution. Now, when you do this, you'll notice that this is creating little circles if we were to revolve a point. And we don't want the volume now, so we don't care about any of the inside stuff. We just want the outside. So the outside of a circle is its circumference. And circumference of a circle, remember, is 2 pi r. So what we need to do here is find the radius here. And if we know that, then I know the length all the way around this circle. And if we were to add up all of these little rings, all of their lengths, we're going to get the actual surface area. So what we're going to do is take little bands or strips of this surface of revolution. And you can see the little strip right here. In this strip, we do have a radius. And remember, we can do 2 pi r, and that's going to give me this entire length right here. And what happens is, if we multiply that by this arc length, which remember we had said was s, then we're actually finding all of the surface area of this strip. Okay? And here's where calculus comes in, because if we take those arc lengths all the way across and we let these little strips go everywhere, then we're going to get the entire surface area. So the formula for surface area here is just going to be 2 pi times your radius times, well, this right here is your arc length. And so an easier way to think about this than to memorize this formula is just to look right here. Surface area is going to be 2 pi times the definite integral from a to b of your radius times your arc length. Now again, we could also have horizontal or vertical axes of revolution. So let's take a look at a horizontal axis of revolution. So let's just draw any function here. And let's just say that we're revolving this around the horizontal axis. So let's get an image of what that would look like. Okay, something like this right here. Now the limits of integration here are going to be from a to b, and those are going to be x values. Now if we try to find the radius here, well, that looks like it's just the height of my function. So that's going to be f of x in this case. Okay, and it's going to be some sort of function of x. So you'll notice here with a horizontal axis of revolution, everything is in terms of x. Now let's take a look at a vertical axis of revolution. So here we'll just draw this function. We'll call this f of x. And if we revolve this around a vertical axis, we're going to get it on the other side here. Okay, so we can see our surface area here. Now when we look at this, our radius is going to be right here. our radius is also going to be just an x value. Okay, so if we were to draw in our x-axis, remember this would just trace down to an x value. And one other thing to notice here is that our limits of integration are still going to be x values. So you're coming from this x, which would be a, going all the way over to this one, which is b. So really focus in on where that arc length is, and your limits of integration will still be these x values right here. So in this case, when you're looking at a vertical axis of revolution, notice everything can still be in terms of x. So the only difference between these axes here is what you let the radius equal. Here the radius is going to be a function of x, and in a vertical axis the radius is just going to be x. It's that simple. Alright, so in our examples it says find the area of the surface formed by revolving the graph on the interval around the line. So in number 1 we have the function f of x equals x cubed from 0 to 1. And so that's just right there. And we're revolving that around the x-axis. So it's going to mirror right here. Here's our shape. And you can see the surface that we're looking for. And the only thing we need to find here is going to be our radius and our limits of integration. So here, our radius is just going to be, well, this length from here to here. And since we're going around the x-axis, our radius is just going to be f of x, which is x cubed. Okay, so since finding the surface area of revolution uses the arc length, we are going to have to find our f prime of x, which in this case is just going to be 3x squared. And now we can plug it into our formula. So surface area is going to equal, well remember it's just 2 pi r times the arc length. So it's 2 pi times the definite integral from 0 to 1 of the radius, which is x cubed, times our arc length, so that's going to be the square root of 1 plus our f prime squared, so 3x squared squared, and with respect to x, or dx. Okay, and when we put this into our calculator, we're going to get about 3.563, and because this is an area, we're going to say units squared. Alright, so there we go. Let's go ahead and try number 2. We'll still draw our picture here. So now we have f of x equals x squared from 0 to the square root of 2. And the square root of 2 is about right here. And so we want to revolve this now about the y-axis. So it'll look something like this. We want to find this surface area right here. So now, because we're going about a vertical axis of rotation, which is the y-axis, we need to find our radius, which would be right here. And if we look, the radius is just going to be an x value. So r here equals x all the way along this curve. So no matter where you pick r, it's going to equal x. Okay, it just depends which x value you choose. Okay, so the two things that we need when finding a surface area of revolution is the radius, which in this case is just going to equal x, and we need to find f prime of x so that we can find our arc length. So here, f prime of x is just going to be 2x. And now we can use our surface area formula. So it's going to be 2 pi times the definite integral from 0 to the square root of 2. So notice that even though our axis of revolution is vertical, we still use x values for the limits of integration. Okay, and then it's times the radius. Okay, because you remember it's 2 pi times the radius. And then times the arc length. So that's going to be the square root of 1 plus 2x, or f prime of x, squared. And all this is with respect to x. And we end up getting 13.614 units squared. Alright, so that is surface area of revolution, and we pull in the ideas of the arc length mixed in with the circumference and our integration techniques. And one other thing to notice here is that our limits of integration are still going to be x values. So you're coming from this x, which would be a, going all the way over to this one, which is b. So really focus in on where that arc length is, and your limits of integration will still be these x values right here.